Welcome to this explainer. If you're an academic, a researcher, or working in R&D, you know the feeling all too well. Trying to do a thorough literature review these days can literally feel like trying to drink from a fire hose. So today, we're going to build a modern, AI-powered toolbox specifically designed for comparative bibliographic searches. We're going to conquer that overwhelming avalanche of scientific papers together, and we'll break down exactly which tools to use, when to use them, and most importantly, why.
Okay, let's dive right into this. Here's our agenda for today. We're going to hit the new bibliographic paradigm, discovery search engines, a head-to-head with Elicit and Consensus, citation verification, advanced workflows, and finally, putting it all together in your own research ecosystem.
Section 1, the new paradigm, and the sheer challenge of scale. To really get why these comparative tools are an absolute game changer, we have to look at the massive mountain we're trying to climb. The research landscape has exploded over the last decade. Over 200 million. That's the number of academic papers currently indexed in databases like Semantic Scholar. Think about that for a second. The sheer volume of published knowledge has hit a tipping point where a purely manual literature review isn't just difficult anymore, it's practically a physical impossibility. There literally aren't enough hours in the day to read, filter, and organize all this data by hand without missing critical evidence. We need serious leverage, right? And that is exactly where AI steps in.
Moving on to Section 2, discovery search engines, or as I like to call it, finding the needle in the haystack. Every great research project has to start at the base of the mountain with discovery. Finding those foundational papers without just completely drowning in irrelevant noise. Our go-to tool here is Semantic Scholar, which was developed by the Allen Institute for AI. It is the ultimate discovery engine. Rather than falling down a rabbit hole, opening dozens of tabs just to read incredibly dense abstracts, the AI actually condenses the main finding of a paper into a single sentence TLDR. It's amazing. Researchers are scanning hundreds of search results in a fraction of the usual time simply because they aren't bogged down in heavy academic jargon right out of the gate. Plus, the algorithm prioritizes results using influence scores, so it efficiently separates the real foundational literature from the statistical noise, showing you exactly which studies have actually shaped your field.
Section 3, Elicit versus Consensus, and how we synthesize all this evidence. Okay. Once we've discovered our literature, it's time to guide our expedition up the mountain to synthesis and extraction. This is usually the exact spot where manual reading just stalls out completely. So we're going to compare two heavyweight tools that people often confuse, but they actually serve completely different analytical purposes. And this brilliantly illustrates the whole dichotomy of the modern researcher. On one side, we have Elicit. If you're tackling a massive systematic review, Elicit is going to be your absolute best friend. It's built for structured data extraction. Think highly detailed tables filled with methodologies, sample sizes, and outcomes. On the other side, we have Consensus. Consensus doesn't build tables. It tests specific hypotheses. You ask it an evidence-based question, and it immediately evaluates whether the published literature supports or rejects that specific idea. Let's look at how Consensus actually works in practice with what they call the consensus meter. Say you ask a really targeted question, like, does intermittent fasting improve insulin sensitivity? The AI instantly scans millions of papers and hands you a clear visual breakdown. It'll tell you, based on high-quality evidence, this percentage is in favor, this percentage is against, and the rest is mixed. It gives you direct, peer-reviewed answers. That is an invaluable asset when you just need to quickly establish what the broad consensus says about a highly specific and maybe controversial topic. But let's pivot back to Elicit for a second. If your question isn't a simple yes or no, and you really need comprehensive depth, Elicit takes the baton. Imagine having to extract the exact sample size, patient demographics, and exclusion criteria from 50 different clinical trials. Historically, for a lead researcher, that's a grueling, multi-day task full of messy spreadsheets. Well, Elicit lets you define custom columns and, in about 20 minutes, generates a perfectly structured table evaluating up to 500 sources simultaneously. It literally transforms tedious operational work into an executive-level review generated entirely by AI. Section 4, Citation Verification, Stress Testing the Evidence. So we've successfully extracted our data. But is it actually reliable? Now we've reached the peak of our workflow, verification. This is where we subject our newly extracted evidence to an absolute stress test using a fascinating tool called CITE. That number right there is staggering, over 1.2 billion. That is CITE's database of citation statements. For the longest time, academia overwhelmingly measured a paper's success just by how many times it had been cited, right? It was a pure numbers game. Cite changes those rules entirely. It proves that it's no longer just about how many times a paper is cited, but how it's being cited in context.
The absolute crucial point here is understanding the concept of smart citations. Imagine finding a landmark paper in your field with 500 citations. Traditionally, you'd assume, wow, rock-solid evidence, practically a law of nature. But what if a tool revealed that 50 of those subsequent citations were actually published to directly contradict or refute the original findings? The entire weight of that evidence completely shifts, doesn't it? Cite divides the citation context into 3 distinct categories: supporting, contradicting, or simply mentioning. By revealing whether a paper's core findings actually hold up under the relentless scrutiny of subsequent research, Cite becomes an absolutely essential tool for assessing the risk of bias. Before you base your own overarching conclusion on a specific study, or before you cite it in your final manuscript, this check ensures you aren't building your work on a foundation that the broader scientific community has already torn down. Section 5. Advanced Workflows and Automation with ASReview. Now, for those of you managing massive institutional-level projects like living systematic reviews or huge meta-analyses, we need to talk about advanced workflows. Enter the open-source software ASReview. It utilizes an incredibly smart active learning loop. It essentially works like this. First, you import a massive database of thousands of unread papers. Then, you, the human researcher, act as the oracle. You just start marking a few papers as relevant or irrelevant based on your criteria. Almost instantly, the AI learns from your human decisions and dynamically re-ranks the entire massive list, continuously pushing the papers most likely to be relevant straight to the top of your reading pile.
The real-world impact of this is just profound. By heavily front-loading the most relevant literature, ASReview lets you find nearly all the critical studies while reading only a tiny fraction of the total database. It basically makes up to 95% of your relevant reading simply vanish from your desk. And it does all of this while maintaining a fully transparent, reproducible log of your human decisions for the peer review process. It is a massive force multiplier for any research team.
Finally, Section 6, your research ecosystem, and how we integrate all these tools. All right, so we've seen some incredible, highly specialized tools today, but how does the whole shebang connect? Let's build the ultimate tech ecosystem for your research. This really summarizes our entire journey. The secret to modern research isn't looking for one magical AI to do everything poorly, but using the exact right tool for the exact right phase of your project. For initial discovery and quick landscape sweeps, you fire up Semantic Scholar. When you move deeper into extraction, you use Consensus to test direct hypotheses and Elicit to instantly pull dense columns of structured data. Finally, you move to verification by plugging those findings into Cite to evaluate the true citation context. These tools don't compete, they complement each other perfectly to form a streamlined, bulletproof research assembly line. Which leaves us with this final, rather provocative thought. The way we evaluate, extract, and synthesize scientific literature has changed forever. It's no longer just about finding a relevant paper. It's about extracting its data precisely and verifying its reputation in the ecosystem almost instantly. You now have the workflow, you have the comparative tools, so the question now is, the next time you sit down to build a literature review, will your conclusions survive AI scrutiny? Thank you so much for joining us on this explainer, and I highly encourage you to start applying these tools to your own research today.